Alright, silly people, here's the situation. We're going to be trying to prove the triangle inequality using what we've learned from inner products. That is just that the norm of two added vectors, alpha plus beta, um, is less than or equal to the norm of alpha plus the norm of beta, right? Um, I'll say this, that the norm of a vector um, is just defined as being the square root of um, the vector with itself, the inner product of the vector with itself. So let's define a vector gamma to do this. I'm going to call it alpha plus beta. And so the inner product of gamma with itself will be just the norm of alpha plus beta, right? Or the norm of alpha plus beta squared. Yeah. So I'm actually going to write that on the left-hand side for now. But then on the right-hand side, I'm actually going to do the norm squared of alpha plus beta. It just looks like the ket, or the bra alpha plus the bra beta times the ket alpha plus the ket beta. Carrying that out, it's going to be the inner product of alpha with itself plus the inner product of alpha with beta plus the inner product of beta with alpha plus the inner product of beta with beta. And right now, I'm going to move some stuff over to the left-hand side of the equation because I think it's useful to do so for this next bit that we're going to do. We're going to move the alpha with alpha term and also the beta with beta term, but then leave the alpha with beta plus the beta with alpha on the right-hand side, right? Now what I'm going to do next might make a mathematician mad, but that's okay. But generally, um, any sort of like inner product of something is going to be less than or equal to the mod of said inner product, right? Um, that just being because the inner product of a vector with anything is some kind of complex number. But if you take the mod of that complex number, you're going to get a positive number that ends up being real. Um, but the point is that either it's going to be exactly equal to just the inner product uh, if alpha plus beta are both, or alpha and beta are both real, or it's going to be less than that because, yeah, on this side you'll have imaginary components if both alpha and beta are complex, and over here you'll have none. So less than or equal to. So by the same token, we also have this inequality of the inner product of beta with alpha is less than or equal to the mod of beta with alpha, right? We can add these two equations. The inner product of beta, alpha with beta plus the inner product of beta with alpha is less than or equal to the mod of alpha with beta plus the mod of beta with alpha, right? Now, mods don't care about complex conjugates, so this is actually 2 times the inner product of alpha with beta, right? Schwarz inequality. That was the one that said that the mod squared of the inner product with alpha with beta is less than or equal to alpha with alpha times the inner product of beta with beta. Let's take the square root of this equation, or of this inequality, Schwartz inequality. So we get the mod of alpha with beta is less than or equal to the square root of the inner product of alpha with alpha times the inner product of beta with beta. And then multiply both sides of this inequality by 2. It's less than square root alpha with alpha, beta with beta. So what we have now to write the inequality in full is that the inner product of alpha with beta plus the inner product of beta with alpha is less than or equal to 2 times the mod of alpha with beta, which now we know is less than or equal to the square root of alpha with alpha times the square root of beta with beta. So we'll just keep actually the leftmost part of the inequality will be less than or equal to the rightmost part. And then we're going to use that to go all the way back up here and say that, okay, if you know that the right-hand side of this equation is less than or equal to the square root of this chunk, then also the left-hand side of that equation is less than or equal to this chunk. So, writing that out, the norm of alpha with beta, or the alpha plus beta norm squared minus the inner product of alpha with itself minus the inner product of beta with itself will be less than or equal to, and actually it's really supposed to be a 2 here, and a 2 here, and 2 here. But yeah, 2 times the square root of the inner product of alpha with alpha times the inner product of beta with beta. Cool. Now let's rearrange this inequality, keeping only the norm squared of alpha plus beta on the left-hand side. On the right-hand side, we'll have the inner product of alpha with alpha plus the inner product of beta with beta plus 2 times the square root of alpha with alpha times beta with beta. Now, this on the right-hand side is literally just the square of some kind of linear combination of vectors. It's or linear combination of inner products. So I'm going to tell you that it's the square root of alpha with alpha plus the square root of beta with beta. And you square the whole thing, and that's how you get that last line if you carry that multiplication out. So now we can take the square root of both sides of our equation, and we just get that the norm of alpha plus beta is less than or equal to the square root of alpha with itself plus the square root of the inner product of beta with itself. Finally, we know that those are the definitions of the norm of alpha and the norm of beta. So we've gone and proven the triangle inequality through some gymnastics for sure. All right.